नमस्कार बच्चों, welcome back to the virtual class. In the previous episode, you must have studied about light, the reflection. In today's class, we move further the chapter. Before going to start that, we will do a small recap so that which will help you to understand the further course of the chapter in a better way. As you know that the light reflects when it falls on a smooth surface or highly polished surface. In that, you must have studied what is a reflection and what are the laws of reflection. So the first law of reflection shows that the first law of reflection states that the angle of incidence is always equal to the angle of reflection. That is, angle I is equal to angle R. The second law, you have seen that the incident ray, reflected ray and the normal all lie in same plane. So this is what you have studied in the laws of reflection. Moving further, you must have studied about the spherical mirrors, in which two categories, they are concave mirror and convex mirror, and various terms associated with the spherical mirrors. You must have learned about the image formation in a concave and convex mirror, and also the real and virtual image. Real image is a type of image which can be obtained on a screen, whereas the virtual image can't be obtained on a screen. This means the real image is formed in front of a mirror, whereas virtual image is formed backside of the mirror, as you can see here. To solve the numerical problems, you have studied about the mirror formula. By using mirror formula, we can find the image distance, object distance and focal length. So these quantities can be found out by using mirror formula. And one more thing you must have studied about the magnification, that means the relative extent of the image, the size of the image with respect to the object. In today's class, we will see about refraction. Let us learn what is refraction and various terms associated with refraction. Children, as you know that the light travels in a straight line. That means light follows a straight path. So the path of propagation is a straight line. So to see this, I have a laser light here. When I focus this light, you can see here the light travels in a straight line. Can you see this? And in the lower classes, you must have studied about the transparent object, translucent object, opaque object. What are these materials? As you know that opaque materials are those materials which does not allow the light pass through it, whereas transparent materials are those materials which allow the light pass through it. Now we will see some of the day-to-day experiences, and from these experiences we will try to understand what is refraction and what are the various terms associated with refraction. What are those experiences? What are there inside the water appears to be a glass of water in which a pencil is immersed. Now the pencil is partly immersed. As you can see that inside the water and outside the water, the portion of pencil inside and outside the water appears to be different. That means in the picture you can see that the pencil is at the surface, at the interface, you can see that there is a deflection, as it can be seen that the pencil is somewhat bent in structure, displaced from its original position. Similar other experiences you can see, suppose if lemon is put inside the water or an egg is put inside the water, you can see that the lemon or the egg appears to be bigger in size than its original size. Why it is so? Why does the egg or a lemon appears to be bigger in size when it is put in water? Similarly, why does the pencil appears to be deflected when it is immersed in water? So in this class, we will try to find out the reason why the pencil appears to be bent in structure, why a lemon or an egg appears to be bigger in size. The light which reaches you from the portion of the pencil which is inside the water appears to come from different direction as compared to the light coming from the portion above the water. So that is why it appears bent in structure. Now you may be asking that if the pencil is kept in the water, it gets deflected, whether the same deflection can be observed in some other transparent medium. Dear children, now the relative extent of deflection of the object when they are kept in two different mediums changes medium to medium. Now we have to discuss about the medium. We need to understand about the medium so that we can understand about the refraction. As the light enters from one medium to another medium, the speed of light changes. So the speed of light is different in different media. In some of the medium, the light travels faster. In other medium, the light travels slower. Children, as long as the medium remains same, that means if the light travels in a particular medium, then the speed of light remains constant. Take an example. If the light travels in air, air is the one transparent medium, the speed of light remains same. So the light appears to travel in a straight path. Take another example. If light is focused in water, water is another transparent medium in which the light travels in a straight path. Suppose if the light happens to travel in two different media, for example in air to water. When light enters from air to water, here we have two media, that is air is one medium and water is another medium. When the light enters from air to water, then the propagation of light, the direction of propagation of light will not remain same. That means we can see somewhat change in direction of propagation of light. One more thing you have to understand, that as long as the medium remains same, then the direction of propagation of light remains same. If the medium changes, then the direction of the propagation of light will also change. In the earlier case, what we have seen, when the light enters from air to water, what happens? Instead of traveling in a straight line, the light slightly appears to bend. That means when the light enters from one medium to another medium, then bending of light we can see. This bending of light is called refraction. So now we will see more about refraction. Some of the activities given in your textbook can be practiced at your home level. Now we will see the refraction by using a rectangular glass slab. Now we learn what is a rarer medium and what is a denser medium. Dear children, the speed of light differs in different medium. If the speed of light is more, then the medium in which the speed of light is more is known as rarer medium. And if the speed of light is slow in a particular medium, then that medium is known as denser medium. Take an example. When a light enters from air to a glass slab, here air, the speed of light is more compared to the speed of light in glass slab. Here in the pair of media air and glass slab, air is taken as a rarer medium since the speed of light in air is more as compared to the speed of light in glass slab. Having this information in mind, we try to understand how the refraction takes place in a glass slab. Now look at the picture in which the glass slab is given, and here the light ray enters from the air to the glass slab. As you can see in the clip that a thin intense beam of light is allowed to pass through a glass slab. When the light strikes on the surface of the glass slab, some of the light gets reflected and some of the light goes into the glass slab. At the end you can see the emergent ray. If you see the direction of propagation of light from the other end, you will see that the light is coming in a straight path. However, if you see the direction of propagation of light above and over the glass slab, then you will see a bent structure. Dear children, look at the picture very carefully. Here, E is the incident ray which falls on the surface of the glass slab at the side AB. After that, the direction of light changes inside the glass slab up to O dash. Finally, when the light goes out from the glass slab, then you see the F is the emergent ray which is going out from the glass slab. Now we will learn how the refraction takes place. Children, when the incident ray E strikes on the surface of the glass slab at side AB at a point O, from the point O, we need to draw a normal. Similarly, when the refracted ray gets emerged from the surface of the glass slab at CD at point O dash, once again we need to draw a normal. That means in a glass slab, we need to draw two normals. That is, when the incident ray strikes initially at the side AB, that will become N dash. And when the refracted ray from the glass slab emerges out at a point O dash, one more normal we have to draw, that is M dash. Normal line is drawn on the point perpendicular to the incident ray. Now in the first case we can see when the incident ray falls on the surface, then an angle is formed. We denote this angle as I1, that is incident angle. After that, when the light enters into the glass slab, we can find the change in the direction of propagation of light. Here you can see that the light is bending towards the normal. If the incident ray is allowed to pass in a straight line, then it would have followed the straight line path, that is G. But it does not happen like that, since when the light enters from a rarer medium to a denser medium, then light bends towards the normal. Now you can see an angle is formed between the N dash and the refracted ray. This angle is known as angle of refraction. In the picture, you can see that the refracted ray inside the glass slab appears to follow a straight path, that is from O to O dash. When it reaches the interface, that is CD at point O dash, then once again refraction takes place into the air. Here we can see the second refraction, that is the light entering from the glass slab to the air. Here glass slab is the denser medium and air is the rarer medium. So when the light enters from a denser medium to rarer medium, then we can see that the light is bending away from the normal. If it would have not bent, then it would have followed a straight path, which is denoted by the letter H. This shows that whenever light enters from a rarer medium to a denser medium, then the light ray bends towards the normal. Similarly, you can see that the emergent ray, that is from O dash, you can see that it bends away from the normal. Now when the light entering from the glass slab to the air, you can see that the light is bending away from the normal, which shows that when the light enters from a denser medium to rarer medium, it bends away from the normal. And one more thing what you can see is the emergent ray is slightly away from its original path. That means a slight shift you can see. This is known as lateral shift. If EF is allowed to make a straight line and GH is made a straight line, you can see that both the lines are parallel. the distance between the parallel line shows that the amount of refraction takes place inside the glass slab, and the two lines are parallel. This is because we have taken a parallel glass slab, that is AB is parallel to CD. Similarly, the normal N dash and M dash is parallel. So when we continue the path of EF and GF, then we get a parallel line. From the parallel line we can also understand that the speed of light in a particular medium is same, that is constant. Now we will see how the refraction takes place. The refraction of light in a pair of media takes place by following certain laws. What are those laws? In refraction we have two laws. The first law states that the incident ray, as you can see in the picture, the incident ray, refracted ray and the normal all lie in same plane. That means the surface, the interface, all these three lines lie in a same plane, that is the interface. Now we see the second law. According to second law, the ratio of the sine of angle of incident ray to the sine of angle of refracted ray is constant, and this constant is known as refractive index, and this law is also known as Snell's law, as you can see here. So sine of I by sine of R is equal to constant. So this, how to find out this refractive index and some numerical problems about the refractive index we will see. Now we learn more about refractive index. As we know that when the light obliquely enter from one medium to another medium, then the refraction takes place, the bending of light takes place. The relative extent of bending of light when enters from one medium to another medium can be calculated by using refractive index. Children, as we know that the speed of light in different media are different, so here the speed of light, the rarer medium and the denser medium is known by using its optical density. As we know that the speed of light changes if the medium gets changed. In a rarer medium the speed of light will be more compared to the speed of light in a denser medium. So here, based on the optical density, we can differentiate from a pair of media a rarer and a denser one. So the refractive index can be linked to an important physical quantity, that is speed. So the refractive index can be calculated in a different media by using speed of light in different media. As we know that the light travels fastest in vacuum with the speed of 3 into 10 to the power 8 meter per second. In air, the speed of light is only marginally less as compared to that in vacuum. As we go further, for example water, the speed of light is very less. So when we take various examples of transparent medium, we can see the difference in the speed of light in those medium. So the refractive index for different medium can be calculated by knowing the speed of light in different media. To know the refractive index for different medium, we can use an expression. Look at the picture which shows the expression for refractive index. So here N21, here 2 is the second medium and 1 is the first medium. So the N21 refers that, for example, if light enters from air to glass, we know that air is a rarer medium and glass is a denser medium. So to find the refractive index of a glass, the expression can be written as NGA. Here G refers to the glass and A refers to air, which is equal to the speed of light in medium 1 divided by speed of light in medium 2, which means speed of light in air divided by speed of light in glass. See here NGA, G is the medium for which we need to find the refractive index. The medium for which refractive index need to be calculated should come under the denominator, and speed of light in another medium from where it gets entered is written in the numerator. So we can say that NGA is equal to the speed of light in air divided by the speed of light in glass. So by knowing the speed of light in air and speed of light in the glass, we can find the refractive index. The relative extent of bending of light when the light enters from one medium to another medium can be understood by knowing its refractive index. Look at the picture. Children, as you can see, air has the refractive index 1.0003. Moving forward, you can see I is 1.31. Likewise, at the end, you can see the diamond, which has refractive index 2.42. So from this, we can say that the bending of light will take place in diamond in the larger extent as compared to air. When light enters from one medium to another, say for example, when the light enters from air to another medium may be water, diamond, glass slab, whatever. If the first medium is, the rarer medium is air, then the refractive index of the second medium is known as absolute refractive index, or simply we can say that the refractive index. Look at the screen how the absolute refractive index can be represented. And one more thing, the ability of the light to be refracted can be understood in terms of optical density. The medium which have more optical density will refract more light, whereas the medium which have low optical density, the speed of light will be more and the deviation is very, very less. And the optical density and the mass density is different. For example, in the table you can see that water is having low optical density than kerosene, whereas in the mass density, if you see, kerosene is lighter than water. So which shows that optical density and the mass density is different. Now we will see some of the numerical problems on refractive index. Now see the first question. Look at the first question. The velocity of light in air is 3 into 10 to the power 8 meter per second. Calculate velocity of light in diamond of refractive index 2.5. Now in this question, refractive index of diamond is given, the speed of light in air is given. So knowing the formula n is equal to V1 by V2, by using this formula we can find out the speed of light in the diamond. So first thing what we need to do is, whatever the things given, that has to be written first. So here given, firstly the velocity of light in air. So velocity of light in air is given as 3 into 10 to the power 8 meter per second. Secondly, the refractive index is given as 2.5. So refractive index can be written like this. Refractive index can be written as NDA. Here D refers to diamond and A refers to air. The refractive index shows that the light enters from air to diamond. Its value is already given, which is 2.5. Now what we need to find? Here velocity of light in diamond. So that also you can write velocity of light in diamond is equal to, we don't know, we have to find. So by using the formula we know that NDA, that means when the light enters from air to diamond, the refractive index formula we can write like this. So here the formula will be speed of light in air divided by the speed of light in diamond. So we know that by rearranging this equation, how can we write? Here speed of light in diamond is equal to the speed of light in air divided by the refractive index, that is NDA. So the values are given. So the value of speed of light in air is given as 3 into 10 to the power 8 meter per second, and the refractive index is 2.5. By substituting these values, how can we write? Here 3 into 10 to the power 8 meter per second divided by 2.5. Further solving this, we will get 1.2 meter per second. This is our required answer. So this is the speed of light when light enters from air to diamond. Now look at the second question. The refractive index of water is 4 by 3 and of glass is 3 by 2. What is the refractive index of glass with respect to water? Since the ratio is given, refractive index is given, refractive index of water to air is given, and refractive index of glass to air is given. Now how to solve this? Look at the screen. To solve this, first we write whatever the things given in the question. So what are all the things given? Now refractive index of water is given. So symbolically we can write NWA. When the light enters from air to water, so refractive index of water is given as 4 by 3, right? 4 by 3. And refractive index of glass is given, so we can write GA. So in both the cases, the light enters from air to glass and air to water. Here refractive index of glass is given as 3 by 2. Now we have to find the refractive index of glass with respect to water. How can we write? N glass with respect to water we have to find. How can we find? Now we have to let the speed of air be c. As the refractive index of water is given, so the equation can be written as speed of light in air divided by speed refractive index of water. So refractive index of water to air, this we can write. Now similarly, speed of light in glass can be written as speed of light in air divided by refractive index of glass. So refractive index of glass is GA. Since we know that speed of light in air is c, so by replacing the values, how can we write? Here we can write it as speed of light in air is c divided by NWA, and next equation can be written as c divided by NGA, right? Now we have speed of light in water and speed of light in glass. So knowing this information, we can find the refractive index of glass with respect to water. So how can we write? Refractive index of glass with respect to water is equal to speed of light in water divided by speed of light in glass. Now we know that speed of light in water is c by NWA. So this equation can be written as NGW is equal to the speed of light in water. Speed of light in water is C by NWA divided by speed of light in glass is C by NGA. So by solving this, what will we get? C by NWA multiplied by, this goes up, so here NGA divided by C. So here C and C gets cancelled. So here we can write NGW is equal to NGA divided by NWA. Since in the question the value of NGA and NWA, that is the refractive index of glass and water, are given as 4 by 3 and 3 by 2. So substituting these values, here glass, the refractive index of glass is 3 by 2 divided by the refractive index of water is 4 by 3. So we can write like this, by 3 by 2 multiplied by here 3 by 4. So here we can write it as 3 3s are 9 divided by 2 4s are 8. So here what will be the answer? 8 1s are 8, 1 2 5 is the refractive index. So this is our required answer, and this kind of questions are very often asked in the CBSE examination. So dear children, so these type of questions you practice at home. In the home assignments also I'll give some of the questions for practice. Do practice at home. So that's all for today. So remaining portion of this chapter we will see in the next episode. So based on today's learning, I would like to give some home assignments which you can practice at home. Here is your home assignment. You can do all these home assignments very easily at home. In case of any queries, any doubts, you can post to us so that you can get clear all your doubts. Keep learning. Take good care of yourself. Bye.